welcome to the SWS Naatu series. And my name is Tejaswini Uma Sudhir. Today, in this particular video, I'm going to be revising some very important numericals which I have taken from various pre-board papers which you certainly need to solve before you go for your board exam on the 17th of March. So I'm going to be solving these numericals and I want you to actually pause this video, solve the numerical and then look at the solution I am providing. If you do not know how to solve the numerical, don't get disappointed. Just look at how I'm solving it and try to do similar questions. Practice. This is the last leg of preparation and it is a time for you to be practicing before you write your board exam, so that while you are actually writing your board exam paper, it is easy for you actually to remember all the formulas and actually apply it in your paper. So let us start. So the problem one says that a person standing between two vertical cliffs and 480 meters from the nearest cliff shouts. See, here's the first echo after 3 seconds and the second echo 2 seconds later. They're asking you to calculate the speed of the sound. So this is from the sound chapter. It's a very simple question. So in this question, they're talking about the concept of echoes. So एक बंदा है जो दो vertical cliff के बीच में खड़ा हुआ है. So what we first do is that we try to visualize how it looks like. Whatever is the first obstacle, usse echo hoga. So let us first write what all is given in the particular question. Distance of the nearest cliff D is 480 meters. Time of the first echo T1 is 3 seconds. And time of the second echo is 2 seconds later. That is, second echo 5 seconds ke baad sunai padta hai. So to find the speed of sound V, the formula is what you need to be collecting right now. To find the speed of the sound, it is the total distance traveled by sound, which is 2d, and the speed of the sound, which is total distance traveled by the time taken. So speed formula is 2d by t, distance by time, 2d by t, because when the person is shouting, it has to go to the obstacle and come back. So it is 2d divided by the time taken. So what it comes out to be is V is equal to 2 into D by T1, which is 2 into 480 meters by 3 seconds, which is 960 by 3, which is 320 meters per second. One thing which you need to be remembering while you are solving the particular question is that you need to always write the units. Once you get the answer, write the units, and it's preferable that you actually block your answer. In this particular case, we have highlighted it. You can actually block your answer in your answer script. So our tech team, Aditya from our tech team has actually created this PPT so that it's easier for you to actually see all the answers and solve it along with me. Our next question, problem number 2, is that 3 identical bulbs A, B and C, each of rating 100 watts, 220 volts, are connected to the mains 220 volts as shown. The diagram is given to you. My throat is pretty bad. I'm having a viral. How is the bulb A connected with the mains? At what voltage does it glow? The second part of the question is that how is the glow of bulb A and C affected if bulb B gets fused? Give reason to support your answer. So let us go part by part. This is a simple question related to electricity, right? So let us first, as usual, write down what is given. What's given is that the power rating of the 3 identical bulbs, A, B and C, all 3 of them, it is 100 watts, 220 volts. Right? And they're connected to the mains, which is 220 volts. That's all what is given to us. Right? Now, what we need to do is that we can see, we know the concept of parallel and series, right? So bulb A is connected in parallel connection with the mains. Right? So when a bulb is connected in a parallel connection with the mains, it means that the bulb is connected to the same voltage source as the other devices in the circuit. So bulb A will glow to its maximum power of 100 watts when the voltage applied across the bulb is 220 volts, right? And that is the first question. The first question was that at what voltage will it actually glow? So it will glow at 220 volts. So what we need to remember is that agar parallel mein connected ho, the voltage of the mains will be equal to the voltage at which the bulb will glow, right? The second part says that what happens when one bulb, that is bulb B, is fused. So let us cancel that off. So when bulb B gets fused, the circuit gets opened, right? So when the circuit is open, the current from the main supply will now go to bulb A. That is 220 volts of the main supply voltage across the mains is now fully applied across bulb A, right? So bulb C will get no current. Hence, the current flowing through C will be 0. The current flowing through C will be 0 because bulb B is fused, right? Thus, bulb A glows with maximum brightness as power consumed is maximum 100 watts and full 220 volts is applied to it. Bulb C stops glowing. It doesn't glow as power consumption of C is 0. That is because bulb B is fused. That is the solution. Now let us go to problem number 3. I hope whatever I have explained so far is very clear to you. If you have any doubts, do write in the comment section. So problem number 3 says, two pendulums C and D are suspended from a wire as shown as in the figure. Figure mein diya hua hai. Pendulum C is made to oscillate by displacing it from its mean position. It is seen that D also starts oscillating. So now there are 4 subparts to this particular question. This is a 4-mark question. This is taken from one of the pre-board papers. From various, we actually look at so many pre-board papers and try to look at the questions which we can actually bring to you in this concise video, which will actually help you revise all the concepts really well. So the first bit says that name the type of vibration C will execute. Then they're asking you the type of vibrations that D will execute. Then they're asking if the length of D is made equal to that of C, then what difference will you notice in the oscillations of D? And the fourth is that they're asking you what is the phenomenon. Each of this is 1 marks, right? 1 mark. So the amplitude of oscillation decreases with respect to time. This type of oscillation executed by C is called damped oscillation, right? So the oscillation performed by C will be damped oscillation. Then the next one is that the D oscillates because of the external periodic force. When pendulum C starts oscillating, what time period D also starts oscillating. So this is that means that the oscillation of D is the action of external periodic force. So therefore, it is called forced oscillation. These are these terms you need to be remembering. If they have asked you almost like a practical example, deke type kuch hai. If it's a very direct question, they may say that define forced oscillation, define damped oscillation. या फिर ऐसा हो रहा है, what is the name of the concept is what is being asked, right? Next is that when the length of pendulum D is equal to the length of pendulum C, kya hota hai is what is asked. In the particular diagram, it is given when it's in different lengths and we have told what type of oscillation. Now, let us assume a case in which C length is equal to D length. So pendulum D starts executing oscillations of a very large amplitude. So amplitude of oscillation will be increased, right? So pendulum D will start executing with a very large amplitude. So what does that mean? The amplitude will be very, very large. I hope you know the definition of what an amplitude is. So what is the phenomenon? This is something very known. You have several give reasons based on this particular phenomenon. I hope each one of you out here actually knows the answer to this question. It is nothing but that the fact that the pendulum oscillates the same frequency of external periodic force is equal to the natural frequency of vibration, and this is known as resonance. I remember when I wrote my board exam, there was a give reason, a very twisted give reason based on resonance. The resonance concept is very important, and you may have several questions based on the resonance concept. For example, in a vehicle, about how there will be a sound when it's moving, or soldiers. There are several give reasons based on this simple concept of resonance, which you need to be remembering. One of the keywords are very important in physics. What you need to be remembering is about frequency being equal, of the external vibration frequency being equal to the natural frequency of vibration. This is the phrase you need to be remembering if anytime you write even a numerical or a give reason question based on the phenomenon of resonance, right? Next question, let's go to problem number 4. I hope all of you are clear up to here. Problem number 4 says, which is again now based on electricity. I had got a lot of comments in my previous video that the electricity pe numericals ka to bahut confusion hota hai. So I have brought you a few numericals. These are the key concepts which actually come. And based on the numericals I have given in this particular video, I really want each one of you to solve many numericals based on the concepts which I have covered in these videos, so that you're actually perfect before you go for your exam on the 17th of March. So 2 resistors are connected in series are shown in the diagram. Okay, now again 4 samples. Look at the diagram. Now they're asking you, first bit says, what is the current through the 5 ohm resistor? 5 ohm resistor left पे दिया हुआ है, and the voltage across it is written as 10 volts, right? So what we know is that the potential difference across 5 ohm resistor is 10 volts, across the R ohm resistor is 6 volts, and the value of resistance R1 is 5 ohms. That's what is given to us. Please write in every particular question numerical you're solving. It's very important you actually write what's given to you so that it's for clarity. And even if suppose भगवान ना करे, suppose आपने कोई calculation में गलती कर ली, for the fact that you are actually understanding the question and writing given can actually grant you a few marks, right? And then another important thing which you need to always write in a question is the formula, right? And please box the formula. It makes it look very neat, presentable and direct. ठीक है, formula लिख दिया, 1 mark दे देता है. So Ohm's law आप सबको पता है, V is equal to IR. So we, in this case, first question is what's the current through the 5 ohm resistor? So we do I is equal to V by R, right? So what we come to know is that current through the 5 ohm resistor is nothing but 10 volts divided by 5 ohms, which is equal to 2 amperes, right? So the current through resistor of 5 ohms is 2 amperes. That is your first bit, 1 mark मिल गया आपको. The next question is that when what is the current through R? It says that since the two resistors, as you can very clearly see in the diagram, they are in series with each other, right? So therefore, the current through the resistor R is also 2 amperes. I hope you know all the properties of series and parallel connection. You just need to remember that, and then it becomes very easy for you to actually solve the questions, right? Now, the third bit given is that what is the value of R? They're asking the value of the second resistance. We know the voltage across the R ohms resistor. We know the current passing through the R ohms resistor. V is equal to 6 volts and I is equal to 2 amperes. Hence, V is equal to IR. So R is equal to V by I, which is 6 by 2, which comes to 3 ohms. Therefore, the value of R, that is the second resistance, is actually 3 ohms, right? What is the value of V? V is the V volts, that is the battery voltage is what they are asking. So what we do is that we need to first find the equivalent resistance, right? So since they're connected in series, the equivalent resistance will be the addition. So what you need to remember, in series, R equivalent is equal to R1 plus R2 up to Rn. And in parallel, it is 1 by R equivalent is equal to 1 by R1 plus 1 by R2 and so on, right? So the equivalent resistance will be equal to R1 plus R2, which is 5 ohms by plus 3 ohms, which is equal to 8 ohms. 5 ohms plus 3 ohms, which is 8 ohms. So by Ohm's law, we know that V is equal to IR, so which is equal to 2 amperes into 8 ohms, which comes to 16 volts. That is the value of V. Therefore, the value of voltage is 16 volts, right? Now, let us go to problem number 5 in this particular video. Very exciting. This is based on calorimetry. This is one of my favorite chapters in the entire syllabus. मेरे को ये बहुत अच्छा लगता है. ये और इसका next question मेरे को बहुत अच्छा लगता है. Please stay on with me. This is a very important concept और बहुत मजा आता है. So two solid substances of equal mass are heated at a uniform rate under identical conditions. The change in temperature in the two cases is shown graphically. So क्या करना है आपको? पहले ग्राफ को गौर से देखना है और समझना है. So they're asking you, first bit says what is the melting point, second bit says find the ratio of the latent heat. Latent heat, so be it. So first of all, it is said that they're of equal mass. Please underline the important things in the question. And they're heated at uniform rate, identical condition. Okay, now. So the solution will go on like this. Find the phase change in the graph. So what can we infer from the graph? So we notice that the temperature is increasing, and then the point where it becomes flat is the point where it is actually melting. So the melting point of body number 1, which is the graph upper one, is actually 60 degrees. And the melting point of the body 2, which is the lower graph, is actually 40 degrees. It's very clear in the graph. So melting point of substance 1 is 60 degrees and melting point of substance 2 is 40 degrees. With that, you finish your part A. Second is part B. Find the ratio of the latent heat. Latent heat, I'm sure you know the concept of latent heat. I'm sure all you SWS are actually clear with all the concepts, and this is only the time for you all to do last minute revision to just brush through all the concepts, right? So in order to initiate a phase change and complete it, some energy in the form of heat is required. This heat is called latent heat. I'm sure आप सबको पता था ये, है ना? So for the same amount of mass, body 1 takes 4 units of time, as you can see, from 2 seconds to 6 seconds, and body 2 takes 3 units of time from 4 seconds to 7 seconds, right? So ML1 and ML2, right? So with this, since it's written in the question that they're of equal mass, so M or M kaat sakte ho, and since you have to find the ratio L1 by L2, ratio of the latent heat will be nothing but 4 by 3. So the ratio of the latent heat, if ratio पूछा है तो is 2 डालना है. If there is your fraction, do use the slash. So the ratio of the latent heat is nothing but 4:3, right? This is the solution. It's a very simple question again. Now we come to the last question, problem number 6. I hope you all have stayed with me so far. You all know all the concepts. Nothing will make me more happy than the fact that all of you know all the concepts and you're just brushing through along with me. So problem number 6 says that calculate the mass of ice required to lower the temperature of 300 grams of water at 40 degrees Celsius to water at 0 degrees Celsius. And they've given you all the constant values. That is, the specific latent heat of ice is 336 joules per gram. And the specific heat capacity of water is 4.2 joules per gram degree Celsius, right? These are the values given. This is again a calorimetry based problem. You know what, the 10th class जो हमने जो ICSE में class 10 में calorimetry सीखते हैं वही आप आगे जाके 11th और 12th में करेंगे. और if you are going to be continuing with the science, whether you do BPC or MPC, it's the same concept that carries forward. So ये आप अच्छा कर लोगे तो you know, it gets easier when you're doing 11th and 12th, right? But let's come back to the problem. So let's again, as usual, write all the given. So let M be the mass of ice. Specific latent heat of ice is 336 joules per gram. And the specific heat capacity of water is 4.2 joules per gram degree Celsius, right? So what we need to do is that basically kya diya hua hai? There is water, right? At 40 degrees Celsius. उसमें आप आइस डाल देते हो. आइस डालने पर वो 40 डिग्रीज का पानी 0 डिग्रीज पे आ जाता है. देयर आस्किंग यू कितना आइस डालोगे आप कि वो 40 डिग्री 0 डिग्रीज पर आ जाए, है ना? सो व्हाट वी नो दैट हीट लॉस इज इक्वल टू हीट गेन. वो सब आपको प्रॉपर्टीज पता है ना? हीट एनर्जी रिक्वायर्ड टू मेल्ट टू लोअर द टेम्परेचर इज इक्वल टू M into L, right? So ml q1 we can say is equal to ml, which is m into 336. M is the mass of the ice which we require to find. 336 is the latent heat of ice which you require, right? Heat energy imparted by the water in fall of its temperature from 40 degrees to 0 degrees Celsius is equal to the water into specific heat capacity into fall in temperature. That is ms delta T, right? So basically what you do is that ms delta T will be equal to ml. That is the formula, right? So if there is no loss of heat, ml is equal to ms delta T, as I just told you. So delta T will be 40 degrees minus 0 degrees, which is 40 degrees. M into 336 is equal to 300 into 4.2 into 40. So 4M is equal to 300 into 4.2 into 40 by 336. So 4M is a typo. It is just M. I hope all of you, please excuse me for this. 4 was a typo. It is M is equal to, it's very obvious, right? 300 into 4.2 into 40 divided by 336. So M is equal to 300 into 4.2 into 40 by 336. So M is equal to 150 grams. Therefore, the mass of ice required is 150 grams. So the answer for this particular question, the mass of ice is actually 150 grams. It's a very simple question. All you need to remember is that the principle of calorimetry, heat energy gain is equal to heat energy loss. In this particular case, ml is equal to ms delta T, right? So the mass of ice required is 150 grams. So with this, we come to the end of this particular video in which we are solving some very important numericals from pre-board papers for your ICSE class 10 board examination. do subscribe to Study with Sudhir YouTube channel so that you actually ace all your board exams. We have done, as part of the SWS Naatu series, we have done so many revision videos, so many MCQs and questions we have solved along with you so that you actually ace your examinations, and we are here to help each one of you. Thank you so much for watching and supporting us all through. Thank you.